Hello everybody, we've got another visual pattern challenge here. The challenge, if you choose to accept it, is to look at this visual pattern, and we've got some steps here. Here's step 1, here's step 2, there's 3, there's 4. And the first part of this challenge would be to determine how many puppies are going to be in the next step, in step number 5. And then at a higher level of difficulty, how many in step 43? And can you write an equation that would tell you how many puppies are in any step at all? So if you'd like to accept that challenge, go ahead and pause the video and see what you come up with. In this pattern, I think the first thing to do is just take a look at it and see if you can figure out what's going on. I see one puppy in the first step, and then looks like we've added 2 more, one to the right and one below. And then in the next one, here's the 3 from step 2, and then again, one to the right, one below. So it looks like we're adding 2 puppies every time. I think a good way to keep track of that is with a chart. So I'm just going to make a quick chart here. I'll put the step number and then the number of puppies. So I've got step 1 has 1 puppy, step 2 has 3 puppies, step 3 has 5 puppies, and step 4 has 7 puppies. And when you're looking at a pattern like this that's growing, the next step in the analysis is to see what's the difference between each step. We've already said it looks like they're adding 2 puppies each step, so this difference should be 2. 3 minus 1 is 2. Let's do the same thing for the next thing. 5 minus 3 is 2, and 7 minus 5 is 2. So the difference between each step is 2. And when you have a difference between steps that stays the same from step to step, it's growing at a constant rate. That is a linear pattern. So when we figure out a linear pattern, we figure out an equation for a linear pattern, we can use the equation for a line. And that general equation in the slope-intercept form, we write out as y equals mx plus b. In this case, the y is going to be our total number of puppies in any step, and x is going to be the step number. The m, when you're using this equation to graph a line or to model a line, that m is usually the slope. In this case, we can think of it as the rate of change, or how much the pattern is growing between each step, and that is going to be our 2. So let's put that in. Y equals 2x plus b. So the number of puppies now, y, is going to equal 2 times the step number plus some other number. And we need this number to adjust it to make it work. For example, if this was just y equals 2x, I would put 1 in for x. So the number of puppies is supposed to be 1 in this step. Then I've got my 2, and I put in the step number for x. That would be 1 equals 2 times 1, which is 2, and that's not the case. So this b is sort of our number we can use to adjust it so that it makes this come out. So this would be 2. I'm going to subtract 1. And now 1 equals 2 minus 1, so that's 1 equals 1. So yeah, that works out. So if we make our formula y equals 2x minus 1, it works out for this step. Let's see if it works out for step number 2. I'd put in 3. We have 3 puppies. That's our y equals 2 times 2 minus 1. And yeah, that would be 3 equals 4 minus 1. That works out. Let's try the next one. We'll do one more here. So this is 5 puppies. So that's our y. And then we have the number 2 times our step number, which is 3 minus 1. Yeah, 5 equals 6 minus 1. So this is working out. So this equation looks like the right equation. That makes it pretty easy to figure out how many puppies are in any step. So if we put in 5 in this formula, so y equals 2 times 5 for step 5 minus 1, we'd get 10 minus 1, or 9. And that should make sense, right? We're going up by 2 every time. So step 5, if step 4 had 7, step 5 should have 9. Now this equation comes in really handy when we're trying to figure out step 43. So we can say y equals 2 times step 43 minus 1. 2 times 43 is 86. So that's 86 minus 1, or 85 puppies in step 43. So how did you do? Did you get the right answers? Let me know. Thanks, everybody.